This is part 2 of my Python course recordings. In this second part, I will talk about handling data with the Pandas package. The Pandas library is a core fundamental package whenever you want to interact with data using Python. Technically speaking, you can use native Python data structures such as lists and dictionaries in order to create pretty elaborate and comprehensive data structures, right? Because you could put a list in a list and a dictionary in a list, and then you can essentially create any data structure you would like. However, whenever we think about data sets that have rows and that have columns, like the far majority of data sets that we would work with, these lists and dictionaries start to become relatively difficult to work with. And this is where the Pandas library comes in. Because the Pandas library provides us with two main things. It provides us with a new data structure that is a Pandas data structure that is called a DataFrame. If you ever used R, then these Pandas DataFrames are relatively similar to R DataFrames because they've taken quite some inspiration from those. And besides providing that data structure, it also provides a whole collection, a very expensive collection of operations that you can apply on these Pandas DataFrames. And that includes opening files, saving files, manipulating them, transforming, almost anything you can think of that you would like to do with a data set, you can do with the Pandas library. So the Pandas library is the core element of the far majority of data science work that you will have to do. And it's also a kind of a prerequisite or a requirement for many of the data science packages that you might interact with, such as, for example, scikit-learn. As I mentioned, a data frame is the core element of the Pandas library. And a data frame will look something like this. And it's very much like any other data set you might see in R or Stata or SAS for that matter, because it consists of two elements. It consists of columns, such as in this case, we have a typical auto data set. So we have the make, the price, miles per gallon, etc. And we have rows for which we have data for these different columns. So whenever I talk about a data frame, just think about this. Now within Pandas, you can open up as many data frames as you would like. And this is different compared to some other pieces of software such as Stata, where you can only open up one data set in memory at a given point in time. Whereas in Pandas and Python in extension, you can just open up as many of these as you want. Just like you can make 100 different lists, you can also make 100 different data frames and interact with them all within one Python environment or within one notebook, for example. And then what you can do is you can apply operations to these data frames. So a common one would be create some filter and get a subset or retrieve a subset of data out of these data frames. So for example, here I create a subset where what I do is I say, well, I would like to have those cars that have a price below 3,800, and I would like to have cars that are by a foreign brand. So then I would specify that. I'll say a little bit more about this syntax a little later, but then what we will get is we will get another data frame that conforms to that filter that we apply to it. But just understand that this last data frame is based on the full data frame, but it is a separate data frame in its own right. And you can again apply operations to that new data frame because it's just a data frame like the first one, but then just with a subset of rows. So these data frames can be extremely useful, and they are essentially what you start with whenever you do any data science type of work with Python. So what are we going to discuss in this particular recording? Now, talking about Pandas is a little bit difficult because there's so much to the Pandas library. It has an extremely expensive set of operations that you can do, and there would be way too many for me to record an example of in this particular recording. But what I've done is I've taken the most common ones, and I'll talk a little bit about terminology, and then I'll talk about these specific topics. And then I'll show you and I'll give you a little bit of intuition as to these basic operations. And then hopefully that will give you some form of a theoretical or a conceptual understanding as to how the Pandas library is supposed to be used. And then you can use that whenever you apply it in your own code. So a couple pieces of terminology here. The first thing is that as soon as you open up Pandas or any Pandas code, you're very quickly going to run into a different package that is called NumPy. Now NumPy in many ways is a precursor to the Pandas library, because what the NumPy library provides is it provides you an alternative data structure that does not have rows or columns, but that just provides you a more powerful version of a list. And generally you refer to that as a NumPy array. And these NumPy arrays are very useful if you want to do vector or matrix operations. And they form kind of the core under the hood of what is used by the Pandas library. Now, the reason that this is important is because many of the NumPy operations you can apply directly onto a column or a row of a Pandas data frame. So very often, Pandas does not provide you with its own solution, but it will just say, hey, you can just use the NumPy operation and apply that onto your row or your column. So that's where, generally speaking, you'll see me do this as well. I will always import Pandas and NumPy at the same time because you will generally need both whenever you're working with a Pandas data frame. And the second thing is that when it comes to rows and when it comes to columns, these are under the hood represented as a NumPy array, but within Pandas, they are generally referred to as a series. So you have a Pandas data frame, which is your main data structure, but you also have Pandas series, which is kind of like a 1D version, like a vector, whereas the data frame would be the 2D version, the two-dimensional version, which is almost like a matrix. And then every column is going to be a series and every row is going to be a series. And this is important because that means that any operation that you can apply to a series, you can apply to an whole column, but you could also apply it to an entire row depending on what you give to that operation. But just understand that essentially a data frame is made up out of Pandas series. One thing that is actually very useful about Pandas, and you wouldn't think about this twice normally, is Pandas has a lot of built-in functionality in order to open up common data files. Common data files could be an Excel file, it could be a CSV file, it could be a Stata file, it can be whatever, a SAS file or any other type of file. And it will enable you to do that in a very convenient one-liner type of way. And you can think, well, all of the libraries that I've used before have this functionality. But the thing is that you can open up an Excel sheet with just pure Python, but that will be quite a lot of code in order to process that and then get it into some form of a data structure that you can use in Python. So using the Pandas library is very important just for this specific reason, because you just have one line of code that you would generally expect. You can load in an Excel file, you can load in a CSV file, and then you can apply your operations to it and do whatever you want. And I have examples of all of this in a particular reference notebook that has examples on how to open and save a wide variety of common data types. So you can just look that up there if you want to know how to do that. The same thing applies to saving data. It's just a reverse operation. Again, if you want to save a CSV file, if you want to save an Excel file, using Pandas in order to do that is generally the way to go because it's way easier than using a native Python library. Now, one thing about files, and this is not necessarily Pandas specific, but this is something that I didn't know for the longest time, and I now use it basically every time I use any Pandas data frames, is that your natural inclination would be to save a data frame as an Excel file or a CSV file. But generally speaking, as soon as these become larger, these will take a very long time to load into Pandas. And that's just because an Excel file or a CSV file is a very inefficient file format that comes at the cost of speed, and then it has the benefit that you can open it in Excel. So a better alternative, and I'm save all my files using this alternative file format, is to use what they call the HDF file format. And the HDF file format, you can use it natively in Pandas, and there's alternative libraries that you can use as well. And what it does is it will save your data frame to a drive, and then you can load it back in and continue your operations. But it does so in a way that is extremely fast, in particular relative to an alternative such as a CSV file or an Excel file. So this can save you minutes, sometimes even hours when it comes to loading your data into your Python files. I have examples here on how you can do this, and I also have a little bit of a timing example where I demonstrate you the amount of speed kind of gain that you can get from using these HDF files. So generally speaking, I would recommend you to look into those. There's two caveats to using HDF files. One, they tend to be a little bit larger on the drive, so you need a little bit more storage space, but that's relatively cheap. And the other thing is that obviously you cannot open an HDF file in Excel. So if you want to inspect it, you either have to get an HDF inspection software or you would have to open it up in Pandas and then just kind of look at it that way. A common thing that you need to do if you use Python for research is you need to inspect your data. Inspecting your data is crucial at any point in the process because you want to make sure that you understand what your data looks like and you understand what your operations did to your data frames. Now, if you're familiar with something like Stata, or if you're familiar with RStudio or familiar with SAS, then generally the way you would inspect data would be you open up the data browser and then you look through whatever you want to look at. In Pandas and in Python, there really isn't such a thing. The way that you're expected to inspect your data is by using some of the operations that are in Pandas to pull up the data frame or the rows or the columns that you would like to take a look at. So for example, if you want to get a quick look, you can just use the head command to get the first 5 or 3 or however many rows you want, or the tail command to get the bottom rows. Or you can create a subset or a random sample and you can just run that and it will show up in your Jupyter notebook and you can inspect it that way. I've also provided some examples on how you can use something that gets close to an interactive data browser using the QGrid extension. Whether you want to use that or not, I'll leave that up to you, but just be aware that that exists if you really want to have an interactive data browser. And I have an example here of how that QGrid extension looks, which you can just use within your Jupyter Lab setup or your Jupyter Notebook setup. And then you do get an interactive window where you can do some filtering, some sorting, just for the purposes of visual inspection. Now, one of the operations that you really have to try to understand because you have to use it so often, but they can at the same time also be one of the most confusing ones, is your ability to create subsets of a particular data frame. Filtering, or a query, if you will. And the way that you would do this is in your notebook, you would specify the data frame that you would like to create a subset of. And I can do that, for example, here. I have an example. So here I specify that for the DF auto data frame, I would create a subset. And then what I would do is I would create some square brackets, which you can see right here. And then within these square brackets, I will put my condition to filter out the rows that I would like to keep. And the way that you would do this is you would have to reference the data frame again. And then more specifically, you would have to reference the column within that data frame and then just put it into a Boolean expression. So here, for example, we have df auto, and then we use the square brackets, and that's how we can select a particular column. So we can do df auto, square brackets, and then we put the name of the column, which in this case will be price. And then we say, hey, for that column, we only want to keep those rows that have a price that's below 3,800, where we do smaller than 3,800. Now what this will do under the hood is it will go through all of the rows in that particular column and it will say, okay, this one is above or equal to 3,800, this one is below, and then it will create true, false values for each of these. And then anything that has a true value will end up in your new data frame. And in this case, I actually combine it with 2 different conditions. So I have my first condition, which is the price needs to be below 3,800. And I also have a second condition, and I subset these conditions by putting them into parentheses and then putting either an or an and symbol in between them. And I would say, well, I now want to go and I want to take the foreign column. So I do df auto foreign, and then I say that needs to be equal to foreign. So now what it will do is it will go through the price column and it will decide true, false, true, false, true, false. It will go through the foreign column and it will say true, false, true, false, true, false. And then because I specify the end statement, it will keep any row for which both of these conditions result in true. So then I will end up with the rows for which the price is below 3,800 and for which the car brand is a foreign car brand relative to the US. So that is how you would generally do this. But the fact that you have to mention the data frame multiple times, that can be confusing. There's an alternative query syntax as well, but I feel like if you understand this, this is the more powerful way of doing it. So that's generally worth the effort of kind of trying to understand how this works and then apply it whenever you have to create a subset of data. So how would you create a column? Now, the way that you would create a column is by just specifying the data frame using that same square bracket syntax, specify the name of the column that you would like to assign to that column, and then just do equals and then whatever you want to be put into that column. If what you put there is a single value, then all rows will have that single value. So if I do df auto price trunk ratio and then I say tees as a string, for example, then every row will say the value tees. But if I specify either a list or a series, then it will go through those elements, and as long as I have exactly the same amount of items in my list as I have rows in my data frame, it will just take those top to bottom and it will put those into that column. So here I actually reference to two different columns. So I have the column for price, and I use the dot syntax here. You can specify, or you can refer to columns in two different ways. And I specify the trunk column, and I say, well, divide the price column by the trunk column, and then create a new column out of it, and create that column price trunk ratio. And then I will end up with something like this. But I can also use more advanced operations where I can use a Python function in order to make some more complicated manipulations to existing data in order to generate new columns. So here I have a simple price function where I say, well, if the make is a foreign make, then do the price times 1.5, and otherwise just return the price as is. And then what I can do is I can use the apply operation right here and say, hey, I want to apply this function to my dfauto data frame. Apply that. The axis equals 1 means do that row by row. So go through each of the rows, see whatever that function results, and then return that, and then create a new column out of that, which I call new price. That will have the result of that function that is applied to each of the different rows. So we can apply that function to each of the rows, I get a new column, and then as you can see, that works as intended. And with the combination of these two, you can create essentially any column that you would like to create. Now, one powerful operation is the ability to merge different data frames together. Because let's say, for example, we have a data frame here that has the make, the price, and the miles per gallon. We have another data frame here that has the make as well, but it also has the headroom and the trunk. And let's say we want to combine these two into one data frame. Then we can say, well, we can pick an identifier. In this case, we can say make. And then we can use the PD merge operation where we say we want to merge two data frames together, dfauto p1, dfauto p2. We want to merge that left, which means that we want to merge the dfauto p2 into dfauto p1 and not the other way around. And then we can say we want to do that based on the identifier, which is in this case going to be the make column. And then it will do that. We can assign that into a new data frame that has a merged kind of combination of these two data frames. And then you will see here that we now have merged these two together. There's a whole variety of options that you can put into this merge function. You can provide multiple identifier columns. You can provide additional kind of commands to this. But generally speaking, this is what you would use. You can also use a join operation, which is almost like a merge, but you join on the index. And you can also do a concatenate or append. You can also just add rows onto an existing data frame. Now, one of the final more advanced functionalities that I want to spend a little bit of time talking about is the GroupBy operation. A GroupBy operation is used whenever you want to apply some logic within a certain group. So let's say that you have some time series data for different companies and you want to apply an operation within one specific company. For example, when you create lagged variables. Then you will have to first create a GroupBy object where you tell Pandas, well, I want you to apply these operations within all these different groups. And you do that by specifying GroupBy and then whatever column or columns you would like to create as your groups. And then you can apply different operations to that. So it says you can calculate the mean, you can do counts, you can do kind of a lead lag situations using shift, and you can do a wide variety of operations. All of that is also located in the reference notebook. But understand if you want to do something like that, you will have to use a GroupBy operation. And finally, Pandas data frames also are generally your starting point whenever you want to create visualizations. Whenever you want to create a graph, for example, you would generally start with a Pandas data frame and then either apply an operation to it so that you can transform your data frame into just the data set that you want and then just plot the direct data. Or you can apply a third-party library such as the Seaborn one that will allow you to just feed it a data frame, specify some parameters, and it will automatically convert everything so that you can get a nice visualization out of it. I have examples for 5 different visualization techniques. They're all provided in the reference notebook. So what is next? First of all, make sure that you've watched the first recording and you know how to deal with Python, because that's a fundamental thing you need to understand in order to use Pandas. But then I would recommend you to watch the demonstration video where I show you some basic operations in Pandas, and then you can move on to the problems that I've provided so that you can get some hands-on experience with using Pandas for your data science needs.